On October 3rd, NASA's Perseverance rover captured something moving through deep space. The object is catalogued as 3I Atlas, the third confirmed interstellar visitor. But 7 measurements break every rule we have for comets. Its mass barely changes despite losing material. Its tail points toward the sun instead of away. It contains nickel without iron, which doesn't exist in nature. Light bounces off it like polished metal, not ice. And its orbit threads perfectly between Venus, Mars, and Jupiter in a sequence that happens once every few million years. Each anomaly alone could be explained. All 7 together create a statistical problem. 3 observation windows close by December 19th. The data that could explain this sits on locked servers. And there's one detail that shouldn't be possible. Someone described this object in August, before anyone knew it existed. Here's what makes this different from every other comet we've tracked. Start with the mass. When comets approach the sun, they heat up. Ice turns to gas. Material streams away in the tail. This process creates drag, like air resistance slowing down a car. We measure this as non-gravitational acceleration. For a typical comet, losing mass means the object speeds up or slows down in predictable ways. 3I Atlas loses mass. The Hubble Space Telescope confirmed outgassing, but the acceleration change is less than 15 meters per day squared. That's the equivalent of a fully loaded semi-truck dumping its entire cargo while barely changing speed. Either the object is extraordinarily dense, denser than any known comet, or something else is compensating for the mass loss. Then there's the coma direction. The coma is the cloud of gas and dust around a comet's nucleus. Solar radiation pushes this material away from the sun, always. It's called radiation pressure. Every comet ever observed follows this rule. 3I Atlas breaks it. The coma points sunward. Imagine smoke blowing into a fan instead of away from it. Avi Loeb at Harvard calls this a potential sign of active propulsion. Mainstream astronomers suggest unusual outgassing events. Neither explanation fits cleanly with the other measurements. The chemistry creates a bigger problem. In September, the Very Large Telescope in Chile analyzed 3I Atlas with spectroscopy. This technique splits light into wavelengths, revealing which elements are present. The spectrograph detected nickel emission lines, strong ones, but it found no iron. In nature, nickel and iron are bonded together. They form in the same stellar furnaces. They condense together in protoplanetary disks. You don't find one without the other, like finding salt without chlorine. They're chemically inseparable. Lab experiments confirm no known natural process splits them apart under space conditions. Dr. Jane Greaves at Cardiff University ran independent confirmation. Same result. Nickel without iron. Next is polarization. When light reflects off a surface, it becomes polarized. The light waves align in specific patterns. The degree of polarization tells us about surface texture and composition. Rough, dusty surfaces create low polarization. Smooth metallic surfaces create high polarization. Standard comets show polarization between 20 and 30% at certain angles. 3I Sage Atlas measured negative 2.77% at a 7-degree phase angle. Negative polarization means the light behavior contradicts what porous ice and rock should produce. It matches the signature of polished metal or highly ordered crystalline structures. The orbit adds another layer. 3I Atlas entered the solar system on a path with almost zero inclination to the ecliptic plane, the flat disk where planets orbit. Most interstellar objects come in at random angles because space has no preferred orientation. A flat trajectory is statistically unusual, but the trajectory does more than stay flat. It passes Venus at 0.77 AU, then Mars at 1.67 AU, then sets up a Jupiter flyby at 5.2 AU. Each passage happens within months of the others, creating gravitational assists that alter the path with precision. David Farnokia at JPL's Center for Near-Earth Object Studies calculated the odds. Threading 3 planetary encounters in sequence from an interstellar approach vector happens roughly once every few million random trajectories. It's possible, but it requires the incoming angle, velocity, and timing to align within narrow margins. Then there's the timing itself. 3I Atlas reaches perihelion, closest approach to the Sun, on October 29, 2025. Venus encounter. November 12th, Mars. November 18th, Jupiter. December 2025. Earth's closest approach. December 19th. The object arrives during a planetary alignment window that clusters 4 major encounters within 10 weeks. Orbital mechanics experts note this multiplies the already low probability of the zero inclination approach. Finally, there's a circumstantial detail that doesn't prove anything but raises questions. In 1977, the Big Ear radio telescope detected the wow signal, a 72-second radio burst from space that's never been explained. The signal originated from coordinates in Sagittarius, near the Chi Sagittarii star group. 3I Atlas's trajectory backtraces to within 9 degrees of those same coordinates. 9 degrees is a wide margin in astronomical terms. The connection is loose at best, but SETI researchers have noted it's close enough to warrant targeted radio observations during the approach windows. The Breakthrough Listen project has allocated telescope time specifically to scan 3I Atlas for structured emissions. So here's where we stand. 7 independent measurements. Each one deviates from comet norms. The odds of all 7 occurring together in one object are difficult to calculate because we don't know if they're truly independent. If they are, the probability drops into fractions of a percent. 3 tests are scheduled. October 29th, perihelion observation at 68 kilometers per second. November 2nd through 23rd, ESA's JUICE spacecraft dedicates 3 weeks to tracking 3I Atlas from deep space. December 19th, closest Earth approach at 1.88 AU, with every major observatory watching. But there's a problem. On October 1st, the US government furloughed 15,000 NASA staff due to budget failures. The Perseverance team uploaded raw telemetry from the October 3rd capture. Mars Reconnaissance Orbiter captured follow-up frames. Mars Express and the Trace Gas Orbiter have additional high-resolution data. All of it sits in processing queues. No one can verify the imagery. No one can run trajectory confirmations. No one can cross-reference the spectroscopy with updated models. The data exists. The scientists who can interpret it are locked out. Avi Loeb has publicly demanded data transparency. His argument: if this object poses even a small probability of being non-natural, the public deserves real-time information. NASA's position, standard protocol, requires peer review before release, and the furlough prevents that process from moving forward. Meanwhile, Mars orbiters continue capturing frames. The queue grows longer, and the observation windows keep closing. The Perseverance capture wasn't accidental. NASA's Jet Propulsion Laboratory provided exact ephemeris coordinates, the predicted position of 3I Atlas, based on its calculated orbit. The rover's navigation camera stacked 20 frames over a 6-minute exposure window. When the images processed, the object appeared precisely where the mathematics said it would be. This confirmed 2 things. First, the trajectory calculations from ground-based telescopes were accurate. Second, 3I Atlas was real, not an artifact or misidentification. But the confirmation created a bottleneck. Perseverance's raw telemetry uploads to NASA's Deep Space Network. From there, data moves to the Planetary Data System, a multi-stage archive where mission scientists validate and catalog observations. The process typically takes weeks, even under normal operations. October 1st changed everything. Congress failed to pass a continuing resolution. Federal agencies entered shutdown protocols. NASA furloughed 15,000 staff members, keeping only essential personnel for active missions and safety-critical operations. Perseverance is classified as active, so the rover continues operating. The DSN antennas still receive transmissions, but the planetary data system team was furloughed. So were the trajectory analysts, the spectroscopy experts, the orbital mechanics specialists who cross-reference comet behavior with mission data. Think of it like this: the evidence exists, but the people who can verify it are locked out. Mars Reconnaissance Orbiter captured follow-up observations on October 7th and October 11th. MRO's high-rise camera can resolve objects down to 30 centimeters from orbit. At the distances involved, 3I Atlas would appear as a sub-pixel target, but the camera's spectral filters could confirm outgassing composition and measure coma structure in detail. Mars Express, operated by the European Space Agency, also targeted 3I Atlas. ESA doesn't face the same furlough restrictions, but their data-sharing agreements with NASA create delays. Protocol requires cross-validation before public release, especially for interstellar objects, where misidentification could trigger false conclusions. The Trace Gas Orbiter added infrared observations. TGO specializes in atmospheric chemistry, but its instruments can detect volatiles, gases escaping from the comet's surface. This data would resolve whether the sunward coma is caused by unusual vent placement or something else. All three orbiters uploaded their observations. All three datasets sit in processing queues. Avi Loeb posted on October the 9th, demanding immediate transparency. His argument focuses on risk assessment. If there's any non-zero probability this object is non-natural, delay creates two problems. First, it prevents the scientific community from mobilizing resources, telescopes, radio arrays, spectroscopy networks. Second, it denies the public information about something potentially unprecedented. NASA's response emphasized protocol. Raw data requires calibration, correcting for instrument noise, atmospheric distortion, pointing errors. Releasing uncalibrated data invites misinterpretation. The agency's position: rushing analysis serves no one if the conclusions turn out to be wrong. The standoff continues. Every day of furlough adds to the backlog. The Perseverance team estimates at least 40 hours of processing time per dataset under normal conditions. With skeleton staffing, that timeline extends indefinitely. Meanwhile, 3I Atlas continues its approach. The object has already passed 2.1 AU from the Sun. Surface temperature is rising. If this were a standard comet, outgassing should increase, creating more pronounced tail structures and stronger spectral signatures. Ground-based observatories track it nightly. Amateur astronomers with 12-inch telescopes can now detect it as a magnitude 11 object, too faint for naked eye, but accessible to serious hobbyists. These observations provide position confirmation, but lack the resolution to measure the anomalies that matter. The critical data remains locked. The images that could confirm or debunk everything sit on servers, unseen. Let's break down what makes these measurements unprecedented. Each anomaly follows the same structure: the data, what it means in plain terms, and why it matters. Anomaly 1, the mass problem. Normal comets lose between 100 and 1,000 kilograms per second near perihelion. This creates measurable drag. Hubble confirmed 3I Atlas is outgassing. Material is definitely leaving the surface, but trajectory analysis shows acceleration changes below 15 meters per day squared. Translation: imagine a semi-truck dumping its entire cargo while barely slowing down. The mass loss should create drag proportional to what's leaving. It doesn't. Either the object is far denser than any known comet, requiring an interior composition we've never measured, or something is actively compensating for the mass loss. Anomaly 2. Sunward coma radiation pressure from the Sun pushes comet material outward. Always. The tail points away from the sun, regardless of the comet's direction of travel. This is Physics 101. 3I, Atlas's coma points sunward. Translation: smoke blowing into a fan instead of away from it. Two explanations exist. First, asymmetric outgassing vents on the surface could create thrust that overcomes radiation pressure. Second, active propulsion. Neither fits cleanly with the other measurements, and asymmetric venting alone shouldn't produce this pronounced an effect. Anomaly 3. Nickel without iron. The Very Large Telescope detected strong nickel emission lines in September. No iron lines appeared. Dr. Jane Greaves at Cardiff University ran independent confirmation using different instruments. Same result. Translation: you're finding salt without chlorine. In stellar formation, nickel and iron condense together. They're bonded at the atomic level in space environments. No known natural process separates them. Lab experiments trying to recreate the conditions found in comets have never produced isolated nickel. This is where the chemistry gets weirder. Anomaly 4. Polarization. Signature: light reflecting off surfaces becomes polarized based on texture and composition. Rough, dusty comet surfaces produce 20 to 30% polarization at certain phase angles. 3I Atlas measured negative 2.77% at 7 degrees. Translation: light bounces off this like polished metal, not dirty ice. Negative polarization indicates either highly ordered crystalline structures or smooth metallic surfaces. No natural comet has produced this signature. It's not impossible. Certain mineral formations could theoretically create it, but no one has demonstrated how. Anomaly 5. Zero inclination orbit. Most interstellar objects enter the solar system at random angles because space has no preferred direction. 3I Atlas came in nearly flat to the ecliptic plane, the disk where planets orbit. Unusual but not impossible. But the trajectory threads Venus at 0.77 AU, Mars at 1.67 AU, and sets up a Jupiter flyby at 5.2 AU. David Farnokia at JPL calculated this sequence. For a random interstellar approach to hit 3 planetary encounters in succession requires the incoming velocity, angle, and timing to align within extremely narrow margins. Translation: threading 3 needles with one throw. The odds sit around 1 in several million for random trajectories. It can happen naturally, but it raises an uncomfortable question about intention versus coincidence. Anomaly 6. Conjunction timing. The planetary encounters cluster within 10 weeks. Perihelion, October 29th, Venus November 12th, Mars November 18th, Jupiter December. Earth's closest approach, December 19th. This alignment window doesn't repeat on human timescales. For an interstellar object to arrive precisely during this configuration multiplies the already low probability of the flat trajectory. If the orbit were designed for maximum observational access to inner solar system targets, this is exactly the path you'd choose. Anomaly 7. Wow, signal coordinates. In 1977, the Big Ear telescope detected a 72-second radio burst from Sagittarius. The signal was never explained and never repeated. 3I Atlas's trajectory backtraces to within 9 degrees of those coordinates. 9 degrees is wide. This is circumstantial at best, but it's close enough that Breakthrough Listen allocated telescope time to scan for structured radio emissions during approach windows. If this object is transmitting, we'll detect it. If it's silent, the coordinate match is coincidence. Here's what's confirmed, what's pending, and what's speculation. Confirmed. All 7 measurements are verified by multiple independent observations. Pending. Explanations that account for all 7 simultaneously. Speculative. Any conclusion about artificial origin without radio detection or surface imaging. The question isn't whether each anomaly is real. The question is whether they're independent. If they're connected, If one underlying cause produces multiple effects, then the probability calculation changes completely. Only one way to find out, and the clock is ticking. Two frameworks exist for interpreting this data. Both deserve serious consideration. The artificial hypothesis. A.V. Loeb's position rests on multiplied probabilities. 7 independent anomalies, each with low individual odds, compound into vanishingly small combined probability. His calculation: if each anomaly has a 10% chance of occurring naturally in isolation, 7 together drop below 0.001%. SETI researchers ran power calculations. To produce a WOW-class signal detectable from Earth at 1977 distances requires a megawatt-scale transmitter. That's enormous, but not physically impossible for advanced technology. If 3I Atlas were deliberately signaling, the same transmitter observed from current distances would appear much brighter. Radio telescopes should detect it easily during November and December observations. The remote viewing correlation adds a controversial data point. In August, blind protocol sessions described a thumb drive-sized device pulsing transmissions, active masking, and surface inscriptions. These sessions were time-stamped before public knowledge of the Perseverance capture. The descriptions are specific. The timeline is documented. Remote viewing isn't scientific method, but the correlation remains unexplained. The natural hypothesis. Mainstream SETI and planetary science emphasize prior probability. Interstellar objects are rare. Artificial interstellar probes are, as far as we know, non-existent. Starting from a baseline where the prior probability of artificial origin is less than 1 in a million, even unusual measurements don't overcome that threshold without extraordinary confirming evidence. The anomalies may not be independent. Unusual composition could explain both the nickel signature and the polarization. Active outgassing could explain both the sunward coma and the mass acceleration discrepancy. The orbital alignment might result from observational selection bias. We notice the objects that pass close to multiple planets because those are the ones we can study. Small sample size creates outlier risk. 3I Atlas is only the third confirmed interstellar object. With 3 data points, statistical norms are meaningless. 1 in 3 showing unusual properties doesn't prove anything except that our models are based on limited data. What would falsify each position? For artificial, finding a natural chemistry explanation that produces isolated nickel, or observing fragmentation at perihelion consistent with icy composition. For natural, confirming non-gravitational acceleration that can't be explained by outgassing, or detecting structured radio emissions with information content. Only one way to find out, and the clock is ticking. 3 observation windows will determine what 3I Atlas actually is. October 29th, perihelion. Closest approach to the Sun at 136 AU. Surface temperature peaks. If this is a standard comet, thermal stress causes fragmentation. The nucleus splits apart. Mars orbiters will capture the highest resolution frames at 68 kilometers per second, flyby velocity. Watch for outbursting, structural breakup, or acceleration changes that can't be explained by outgassing alone. November 2nd, 23rd, JUICE spacecraft observation. ESA's JUICE mission is en route to Jupiter. For 3 weeks, the spacecraft dedicates instruments to 3I Atlas from a deep space vantage point. This angle is unique. Earth-based telescopes can't replicate it. Mission-confirmed instruments include cameras and spectrometers. Miss this window, wait decades for another interstellar object with similar geometry. December 19th, Earth closest approach. Final verdict at 1.88 AU. Fresh parallax measurements. Trajectory confirmation. Global Observatory Network activates. Professional telescopes, radio dishes, amateur networks. David Farnokia's checklist. Verify non-gravitational acceleration. Confirm spectroscopic composition. Detect or rule out radio emissions. 3 predictions to test. JUICE will detect or won't detect sustained outgassing signature. The nickel anomaly will be explained by new chemistry models or remain unexplained. December reacquisition will show either fragmentation debris or structural integrity. We'll analyze the actual results when data releases. You'll see if these predictions hold. But even if all tests run perfectly, there's one piece of evidence that shouldn't exist. In August 2025, Birdie Dworsky's team ran blind remote viewing sessions. The protocol: trained viewers received coordinates with no context, no information about what they were targeting. Sessions were time-stamped and sealed before any public knowledge of 3I Atlas. The descriptions were specific: thumb drive-sized device, pulsing bursts of transmission, active masking or camouflage, surface inscriptions or markings, language that later appeared in viral theories after the Perseverance capture went public. Remote viewing isn't scientific method. It doesn't substitute for measurement. It doesn't prove anything about what 3I Atlas is. But here's what's undeniable. The timeline is documented. The descriptions are specific. The correlation is unexplained. The JUICE spacecraft is watching right now. In 33 days, Earth gets its turn. Whatever 3I Atlas is, we're about to find out, whether NASA's ready to tell us or not. The next image drops when the furlough ends. We'll break down what it shows the moment it's public.